Just use REST, everyone understands it. No, use GraphQL, the front-end fetches exactly what it needs. You're both wrong. gRPC is 10 times faster. Sound familiar? This argument happens on every engineering team, and almost everyone is slightly right and completely missing the point. Because the question is no longer, which API is best? The right question is, which communication boundaries exist in our system, and which protocol fits each one? By the end of this, you'll answer that for any system, every time. Let's get into it. Before comparing them, let's agree on what they all do. When a client needs data from a server, 3 questions always need answering. 1. How do you describe what you want? A URL, a query, or a function call. 2. How is the data serialized? JSON, binary, or XML. 3. What contract exists between client and server? REST, GraphQL, and gRPC just answer these 3 differently, and those answers decide where each one fits. First, REST, representational state transfer. The default API style of the web since the mid-2000s, because it maps directly onto HTTP. The core idea: resources are nouns, HTTP methods are verbs. Get to fetch, post to create, put to update, delete to remove. Every developer knows this pattern. What REST gets right? Every HTTP tool works with it out of the box. And caching is built into HTTP. A GET with the right headers gets cached by proxies and CDNS automatically. But REST overfetches. You ask for a user and get back 40 fields when you needed 4. On a mobile connection, that wasted data matters. And it underfetches. Need a user, their orders, and their payment method. That's 3 separate requests, 3 round trips of latency. Plus versioning pain. Change the response shape and clients break, so you ship version 2 and maintain both forever. REST's value is universality, the right default for public APIs. Next, GraphQL, built at Facebook in 2012, open-sourced in 2015. Born from one pain. The mobile app was drowning in data the REST endpoints returned, but the client never needed. The core idea: one endpoint. The client sends a query describing exactly what it wants. The server returns exactly that, no more, no less. So no overfetching and no underfetching. The client controls the response shape. Mobile gets a light payload, desktop a rich one, same endpoint. That 3-request REST pattern becomes one query, one round trip. And the schema is self-documenting, every type, every field described. But caching is hard. HTTP caching keys on URLs. GraphQL is one post endpoint, so CDNS can't cache it automatically. You need application-level caching. And the N+1 problem. A naive resolver fires one database query per item, plus a complexity tax, depth limiting, persisted queries. GraphQL's value is flexibility for many clients with different needs. Then gRPC, built by Google, open-sourced in 2015. It's the framework Google's own microservices use to talk to each other at scale. The core idea: define your service in a proto file. The compiler generates client and server code in any language. It runs over HTTP2 with binary protocol buffers. From one proto file, you get a fully typed client in Go, Python, Java, or Rust. The calls look like local functions. The network is invisible. What it gets right: raw performance. Binary proto-buff cuts payload 60 to 80% versus JSON, plus native streaming, server, client, and bidirectional, over HTTP2. And strong typing across languages. The proto file is the contract, enforced by the compiler. Schema drift becomes impossible. But browsers can't speak gRPC directly, you need a proxy. And you can't just curl a binary endpoint, so debugging is harder. gRPC's value is precision for internal service-to-service traffic. Let's put the numbers side by side, the same operation. Fetch a user plus their 5 most recent orders. Payload size, REST over 1,200 bytes. GraphQL 834. gRPC just 312, about 4 times smaller. Median latency, REST 12 milliseconds. GraphQL 15, gRPC 4. It wins on both dimensions. But payload and latency aren't the only metrics. Dev speed, debuggability, ecosystem maturity, they all factor into the real cost of an API choice. So here's the framework. 5 questions follow the arrows. 1. Is it a public or external API? Then REST. It has to work with every client and toolchain. gRPC is almost never right here. 2. Do different clients need different shapes of the same data? Then GraphQL, that's exactly what it was built for. 3. Is it internal service-to-service, where you control both ends and performance matters? Then gRPC, but if your team is small or early, REST is still fine. 4. Do you need real-time bidirectional streaming? gRPC natively, just server-sent events. REST with SSE works fine. 5. What's your team's expertise? Every team can use REST today. GraphQL has a learning curve. gRPC needs proto-tooling. An API your team can't debug in production is a liability. Here's the truth most comparisons skip. Most production systems use more than one. The typical 2026 stack. A public REST API for partners, a GraphQL gateway for your own web and mobile, and gRPC between the internal services. Each protocol sits at the boundary it fits best. That's not over-engineering, it's matching the tool to the constraint. The expensive mistakes come from picking one protocol for everything. GraphQL that buckles at scale, REST rewritten for real time, gRPC that killed public adoption. So to recap, REST, universal, cacheable, battle-tested, start here by default. GraphQL, flexible, client-driven, kills over and under fetching, just mind caching and the N+1 problem. gRPC, the performance choice, binary, streaming, typed across languages for internal traffic at scale. And the real answer isn't which one is best. It's which one is best for this boundary. REST outside, gRPC inside, GraphQL where clients need flexibility. This comes up constantly in system design interviews, walk the 5 questions, and that reasoning is what gets you hired. Comment which one you use most. Subscribe, and I'll see you in the next one.